On October 19, 2017, astronomer Robert Warwick was reviewing data collected by telescopes when something unusual caught his attention. The more closely he examined the information, the clearer it became before him was an object unlike anything science had ever encountered. An unknown body in the solar system was moving at an enormous speed of 59,000 miles per hour along a trajectory that clearly indicated it was not captured by the sun's gravity. It was traveling on a path that made it clear that it had come from interstellar space. The speed of the object was far too high for the sun to have pulled it into its gravitational field. Soon scientists established the size of this mysterious object was roughly comparable to a football field, but the real shock came with its shape. It had nothing in common with asteroids or comets known to science. Moreover, the object left behind no gas trail or dust trail, which is entirely uncharacteristic for comets approaching the sun. As research into the mysterious object deepened, the situation became even more inexplicable. Scientists discovered that before it had been detected while it was still outside the reach of our instruments, it had passed dangerously close to the sun, just 23 million mi from its surface, which is closer than Mercury's orbit. And then, something astonishing happened. The object suddenly increased its speed by nearly 3.5 times, reaching an incredible speed of 194,500 miles per hour, or 55 meters per second. It was as if some unknown force had given it a massive additional push. The unidentified interstellar visitor was given the name Oumuamua, M-U-A, which means scout or messenger in Hawaiian. It arrives first from afar, but what exactly this object was could not be determined by the time it was first discovered. Oumuamua, M-U-A, was already rapidly distancing itself from us today, more than 4.3 billion miles from Earth, leaving the solar system behind, and its speed and trajectory indicate that it will never come any closer to us again. Its unusual shape, lack of a gas tail, and most intriguingly, its arrival from interstellar space left scientists baffled. More and more researchers began to lean toward the hypothesis that Oumuamua might not be an ordinary space object and only a synthetic spacecraft, which could be a message from an intelligent extraterrestrial civilization. To test this bold theory, a large-scale project was proposed, Project Lyra. Its task was to send out a probe to catch Oumuamua, get close to it, and finally learn what we were dealing with. With music, the interstellar guest, right after the discovery of Oumuamua, a wave of excitement spread through the scientific community. This object didn't fit into any known category, and no one could say what exactly we had encountered. It challenged everything we knew about space in an effort to capture. A few astronomers around the world urgently repurposed their telescopes and canceled their own research. More signals from it before it vanished forever into the darkness of interstellar space shortly after its discovery. Initial estimates suggested that Oumuamua, M-U-A, measured approximately 1,300 feet in length and 130 feet wide. This elongated shape didn't resemble any known celestial body, but later, as new data arrived, scientists at McMaster University in Canada made their own calculations, suggesting that its dimensions could have been around 380 feet in length, 364 feet wide, and 62 feet thick, making it slightly larger than the Statue of Liberty. However, instead of an elongated cigar shape, the object might have been flat or pancake like in form, but even that shape is very unusual for space objects. Similar proportions have only been seen in rare cases, such as Erycith, a celestial body in the Kuiper belt beyond Neptune's orbit. Even so, such exceptions don't make Oumuamua any less mysterious. Its shape remains extremely atypical and continues to raise concerns because we're witnessing an unusual and enigmatic object speeding through space at a staggering 16 meters per second, which is faster than Voyager 1. One of the fastest spacecraft ever launched by humans. At such a speed, Oumuamua could cross the distance between New York and San Francisco in just 2 minutes and 38 seconds. This velocity indicated that the suspicion that the object was a distant interstellar. The object was quickly confirmed because it was not bound by the sun's gravity. Visitor, but where exactly had it come from, and more importantly, what was it? The first thing astronomers expected to see as they observed the rapidly receding object was a bright tail of gas and dust. After all, they initially assumed it was a comet, and those behave predictably when approaching the sun. Under the influence of solar heat, ice and frozen gases on their surface begin to evaporate, ejecting dust and gas into space. These emissions form a glowing tail that trails behind the nucleus, reflecting sunlight. A vivid example is Comet Hale-Bopp, whose tail was visible to Oumuamua. Oumuamua defied all expectations. Despite being visible to the naked eye from Earth in 1997, music flew past the sun without producing any gas, dust, or other signs of evaporation. Even the faintest hint of a tail, its behavior broke all the rules that apply to ordinary comets. This mysterious guest continued to baffle science. Its shape, trajectory, and incredible speed all pointed to one thing: we were dealing with something completely unique, unlike any object known to humanity. Tension continued to grow in the scientific community. The main question was, is Oumuamua just an ordinary cosmic body, or have we for the first time encountered extraterrestrial technology? But the strangest part was yet to come. It turned out that Oumuamua had accelerated, and not just accelerated but had done so in a way that defied understanding, as if it were following its own plan. Scientists determined that 40 days before its discovery, the object had passed dangerously close to the Sun, just 23 million m from its surface, and it was after this moment that it suddenly gained speed. At its peak, Oumuamua accelerated 254 meters per second, 5 times faster compared to its flyby of the Sun earlier. That speed is truly astonishing. 11 times faster than Voyager 1 is traveling at the moment. The Starship rocket, and 250 times faster than the speed of sound. This kind of acceleration is typically observed in comets when jets of dust and water vapor from their tail give them an additional boost. However, as we already mentioned, Oumuamua showed no signs of such activity. Something accelerated it, but what a MUA? MUA a spaceship. What if this object isn't what it seemed to be? What if 8 years ago, something far more intriguing than a chunk of space, ice, or rock flew near Earth, perhaps a spacecraft created by another civilization? This is the hypothesis put forward in 2021 by astronomer Avi, then chair of Harvard University's astronomy department, along with his colleague, Shul Bali. They proposed that the first detected interstellar object may have been a space probe. The researchers are convinced. There is every reason to believe that MUA's peculiar behavior may be truly unusual. What intrigued scientists most was the moment the object unexpectedly accelerated during its pass by the Sun. Sure, the Sun's gravity could give it a push, but based on calculations, that acceleration should have been much weaker. That's why Avi and Shuli proposed a hypothesis. What if this wasn't just a rock from another star system, but an object using light sail technology at first glance? The idea sounds fantastic, but it's based on real physics. A light sail is a thin and lightweight structure that can move, using the pressure of light. Streams of photons from the Sun, for example, exert a tiny but constant pressure on the surface of a sail, gradually accelerating it to very high speeds without the need for fuel. If Oumuamua had indeed such an ultra-thin structure capable of catching solar radiation pressure, then the solar wind could have given it the extra push. According to their calculations, for this to be possible, the sail's thickness would need to be just 0.3 to 0.9 millimeters, about the thickness of a human hair. Just imagine an object 380 feet long and less than a millimeter thick. They may sound wildly unrealistic, but light sail technology already exists. For example, it was tested by the Japanese spacecraft Ikaros, the world's first probe to successfully use solar radiation as its propulsion source, which successfully journeyed toward Venus in 2010. May have seen something resembling a solar-powered object sail designed to accelerate and change course as it passed by star systems. And if it truly was an artificially created device, it's entirely possible that it had other activities in addition to the sail. Technological components. Ones we can only speculate about for now, but one thing seems obvious: an object like this would need at least a system for scanning its surroundings and a means of communication for the purpose of sending and receiving signals from their creators. Bali and Lob also conducted calculations to determine whether Oumuamua's light, they thought the density of sail could withstand a lengthy journey across the stars, interstellar gas and dust, as well as the speed at which the object would collide with these particles in space. The outcomes were impressive. And if Oumuamua were in fact a device of that kind, it could have remained intact, despite traveling at least 16,000 light-years from its home star system. That said, the scientists themselves don't definitively claim that Oumuamua is a spacecraft. They simply believe that the possibility exists and that it's serious enough not to be dismissed in scientific discourse. The idea of a solar sail is just one possible explanation if we assume that Oumuamua was a real artificial object. Might have been a much more complex and advanced probe, for example, an active unmanned spacecraft sent out to study our solar system, and there are reasons to believe that it was indeed unmanned. Consider this: Oumuamua's speed would allow it to travel 1 light-year in roughly 11 to 11.50 years ago. Contrast that with the distance to the nearest star, Proxima Centauri, which is just over 4 light-years away. That would mean the trip would have taken the Oumuamua around 44 to 46,000 years. Such journeys are simply impossible for living organisms, which means that if this was a ship, it was most likely controlled remotely, either by a program or by someone from afar. However, not everyone shares this point of view. Many scientists consider the idea of a possible spacecraft or artificial object to be overly speculative. In their opinion, there simply isn't enough direct evidence to support such bold claims. Scientists Alan Jackson and Steve Desch from Arizona State University proposed their own hypothesis about the nature of Oumuamua. They suggest it may be a fragment of frozen nitrogen. This type of substance can be found, for example, on Pluto. When the spacecraft New Horizons in 2015, it flew by the dwarf planet and saw icy plains similar to Sputnik, Planeta. Vast lakes of frozen nitrogen. The researchers suggest that a powerful impact could have broken off a chunk of such a surface from a Pluto-like planet, which then embarked on an interstellar journey. As it approached the Sun, the nitrogen began to evaporate from the heat, creating a kind of jet propulsion that could explain the object's sudden acceleration. Meanwhile, two other scientists, Darrell Seligman of Cornell University and Jennifer Bergner of the University of Berkeley, California, has its own take on this baffling object. According to them, Oumuamua was once an ordinary water-rich comet orbiting a distant star, but it was ejected into interstellar space at some point during its long journey through the galaxy. It was exposed to powerful cosmic rays, for example from supernova explosions. These rays could have transformed up to a third of its water ice into hydrogen molecules, which remained trapped inside the ice. Later, when the Oumuamua reached our Sun, it warmed up and the accumulated hydrogen started to escape like tiny jet streams. This is what gave the object an extra push, and strange behavior, like not having a bright tail like typical comets, can be explained by that light hydrogen wouldn't generate enough thrust to carry much dust with it. As a result, we see strong acceleration without any visible trail of dust or gas. Other scientists also share similar ideas to explain this puzzling object. Karen Meach, an astronomer at the University of Hawaii at Manoa, believes that some people choose an even simpler hypothesis, that the object is simply a very ordinary comet but with a very low dust content, hence the lack of a tail and the unusual shape of Oumuamua. Perhaps it's not so rare at all. The fact that it may simply reflect our limited understanding of the universe. What appears unusual to us contains a vast diversity of forms and structures, and a cigar-shaped or disc-shaped object might be much more common than we think. Most of them are likely just too far away for us to observe, although the majority of the scientific community agrees that Oumuamua is most likely an asteroid or an unusual comet. We still have no definitive confirmation of this, which means the central question remains open. How can we ever truly know what this mysterious interstellar visitor really was? Music: a bold mission to catch up with Oumuamua. It's simply impossible to see or discern Oumuamua, even through the most powerful space telescope, as the object is rapidly moving away and is extremely small, almost 3.5 times shorter than the height of the Empire State Building. Seeing such a tiny object at a distance of billions of miles would be like trying to spot Sydney from the shores of San Francisco across the entire Pacific Ocean using ordinary binoculars. Only the Hubble Space Telescope was able to observe this object for a few weeks before it completely faded into darkness. But what if we try to get close to this object and study it? That sounds like a bold idea, but it's almost impossible. But that's exactly the challenge scientists have taken on. As early as October 30, 2017, just 11 researchers from the Initiative for Interstellar Studies announced the start, just a few days after the discovery of Oumuamua, of Project Lyra, which aimed to determine whether a mission that would send a spacecraft could be designed after the interstellar object and study it up close. But is such an ambitious mission even feasible? Engineer and scientist Adam Hibbert, a key participant in Project Lyra and the creator of the Optimum Interplanetary Trajectory software, OITS used for calculating optimal trajectories for interplanetary missions, is convinced the mission is not just about finding out what Oumuamua is, it's a chance to make a breakthrough in our understanding of the entire interstellar realm. According to him, the first step is to create a truly unique probe capable of withstanding the harsh conditions of deep space. It must be reliably protected from radiation, as it will need to travel billions of miles where cosmic radiation is relentless and can easily disable its scientific instruments. Of course, catching up with Oumuamua is not an easy task, but in space mission practice we already know how to achieve extreme speeds without using massive rocket engines or enormous fuel reserves. As part of Project Lyra, engineers plan to launch a probe on a dizzying journey using gravitational assists as massive cosmic slingshots. One of the proposed trajectories is a true planetary dance. The probe would launch from Earth, travel to Venus, where it would receive its initial boost, and then return to Earth to make use of our planet's gravity for a second acceleration. The next step would be to fly toward Jupiter, where the gas giant's immense gravity would give the spacecraft the final push on its way toward the interstellar traveler, Oumuamua. Additionally, the probe would be equipped with chemical propulsion systems that could adjust its course and add thrust at just the right times. Because of an interstellar chase, every mile per second counts. This trick has already stood the test of time. In 1979, the Voyager 1 and Voyager 2 spacecraft used Jupiter's gravity to accelerate dramatically and head towards Saturn. Today's engineers aim to replicate this maneuver, but this time to catch up with Oumuamua. There's also another, far more daring plan, known as the Solar Oryth maneuver. In this scenario, the probe would first travel to Jupiter, then reduce its speed and use the giant planet's gravity to change course and head toward the Sun, as close as physically possible without catastrophic consequences. They're on the edge of hell. It would receive a massive gravitational boost from the Sun and additionally ignite its chemical engines to escape the pull of the Sun and return to Jupiter at incredible speed, accelerating once more with its gravity before finally entering a trajectory to pursue Oumuamua. If everything works out, the spacecraft could accelerate to 0 miles per hour or even up to 163,000 miles per hour. That's 20 to 45 meters per second, precisely. The speed range needed to catch up with the fleeing mystery object and to do it fast enough, but there's a major challenge because the enormous temperature is so close to the Sun that it could heat the probe to 400 C hot enough to melt metal. However, we already have a proven solution, the Parker Solar Probe, which in 2024 set a new record by approaching the Sun at just 3.7 million miles, all thanks to its unique heat shield made of carbon foam, which with the infernal heat, a similar shield is planned for the probe destined to chase Oumuamua. In fact, engineers have already created a 3D model of this spacecraft. Scientists have not yet made a final decision on which route to choose for the probe: the gravity assist dance involving Earth, Venus, and Jupiter, or the perilous solar flyby. Other more exotic methods are also being considered, for instance laser propulsion, in which a powerful ground-based laser pushes the probe through space, giving an acceleration without a drop of fuel, or the previously mentioned solar sails lightweight structures that capture the pressure of sunlight and gradually but surely accelerate the spacecraft across the cosmos. For now, these technologies are more experimental than practical, but they open the door for a new era of fast and efficient interstellar travel. As for the mission to reach Oumuamua, its launch is tentatively scheduled for sometime between 2030 and 2033. The most realistic scenario at this point involves a gravitational dance using Venus, Earth, and Jupiter. In this case, the probe will be able to catch up to the rapidly vanishing Oumuamua at the beginning of the 2050s. Possibly for the first time in history, come face to face with a messenger from another star system. But what if the mission fails? What if the probe is unable to catch up with Oumuamua? What if it approaches the object from a distance too far away? To study it properly, don't forget that this object is finding it in deep space is impossible because it is so tiny and does not emit any light or signals. Nearly impossible. There's another risk: the probe could reach its target, but fail to slow down in time. In that case, it would simply speed past, missing what might be our only chance to get close to our elusive target. Scientist Adam Hybid believes that even in the event of failure, the mission would not be considered a failure. Even if Oumuamua can't be caught, the probe would become a first spacecraft in history to be purposefully sent beyond the boundaries of the solar system. The attempt to chase Oumuamua is also a chance to study the space beyond the solar system and to explore the universe from an extrasolar perspective, which could bring humanity countless benefits. The scientist asserts to date only 2 objects have crossed the heliper, the boundary where the Sun's influence ends and interstellar space begins. These are Voyager 1 and Voyager 2. But their journey beyond the solar system was more a matter of luck. No one expected the probes, which were designed to study planets, to travel so far or for so long. Unlike them, the new probe is being designed from the outset to venture into interstellar space. It will be equipped with state-of-the-art instruments capable of gathering valuable data about the environment beyond the solar system, data we just don't have. In that case, the probe would not only have a chance to catch up with the Oumuamua and answer the question of what this object really is, but also to transmit invaluable data about the mysteries of interstellar space. But what exactly do scientists hope to see if the probe does manage to reach Oumuamua? As already mentioned, most researchers believe this mysterious visitor is merely an unusual comet or asteroid. It is thought to be dense object composed of rock and possibly metals. It contains no water or ice, and its reddish surface likely results from exposure to cosmic rays over millions of years. Once scientists formed a general idea about the composition of Oumuamua, it begged the next question, just as important: what kind of journey brought this object to our solar system? The answer to its true nature might lie not only in what it's made of, but where it came from. In 2018, astronomers attempted to reconstruct its trajectory retrospectively. Calculations showed that about 1 million years ago it flew past several stars. Since it is closest to the red dwarf HIP 3757, it may be interstellar. Journey began. They're heading directly towards us. Another version suggests that Oumuamua might have come from the Vega star system in the Lyra constellation about 25 light-years away. So far, astronomers haven't found any potentially habitable planets in that region, but that doesn't mean they're not there. It's quite possible that somewhere near Vega, a civilization exists that's responsible for the appearance of this mysterious object, and all the excitement is stirred up in the scientific community now. Oumuamua is speeding toward the constellation Pegasus, continuing its strange voyage through space. By the end of 2025, the interstellar visitor will reach the outer edge of the Kuiper Belt, and by November 2038, just 13 years later, when it reaches the it will leave the solar wind-influenced region and enter true interstellar space. Music, it appeared very suddenly and disappeared. Just as quickly, leaving behind more questions than answers. Its fleeting presence stirred the scientific community, and now researchers are determined not to miss the next such visitor from the depths of space. The European Space Agency is preparing a unique mission called Comet Interceptor. Its goal is to intercept objects arriving from interstellar space, but the main challenge is that these kinds of guests arrive at incredible speeds and there simply isn't enough time to prepare and launch spacecraft once it's spotted. Therefore, ESA has made a bold decision. In 2029, they plan to launch a stakeout probe into space, which will be stationed at the Lagrange point L2, about 930 miles from Earth. This is a location where the gravitational forces of Earth, the Moon and the Sun balance out, creating an ideal observational outpost there. The probe will wait patiently, and as soon as an interstellar comet appears on the horizon, it will activate. The main probe will release 2 maneuverable satellites that will pinch the target and begin observation from multiple angles. Simultaneously, most scientists today believe that Oumuamua is an ordinary cosmic body, most likely a comet or asteroid. Others suggest that we're dealing with technology from another civilization, but we cannot confirm either hypothesis yet. The object is already too far away, and its nature remains cloaked in mystery. The chase for the truth seems almost impossible, expensive, risky, and absurdly ambitious. But it's precisely these kinds of mysteries that fire up the imagination, and the desire to know the truth outweighs all obstacles. And what do you think flew past us in 2017, and should humanity spend resources on such missions? Share your opinion in the comments. And now we invite you to return to the object mentioned at the beginning of the video when we discussed the shape of Oumuamua. We're talking about Arrokoth, a distant body in the Kuiper Belt that also holds many secrets. There are millions of strange objects in the Kuiper Belt, some of which are 100 kilometers wide. Some are really huge, measuring 1,000 kilometers in diameter. So what are they? Kuiper Belt objects or trans-Neptunian objects are the remnants of the very birth of our solar system that happened about 4.5 billion years ago. It's a huge volume of space, as you can imagine. While we had just discovered a tiny fraction of this region, we've already found about 2.0 Kuiper Belt objects. However, some of them raise more questions than they give answers. In April 2016, the New Horizons probe reached the dark and mysterious Kuiper Belt. As the probe was moving past Pluto and nearing the belt, it discovered a weird object on a strange trajectory. It was given the name Erin, and it was measured at 133 kilometers in diameter. While researchers were looking at it, it appeared to grow brighter and then dim in a precise rhythm, suggesting it was spinning. Most objects in the belt are made of ice and rock, but this thing seemed to be made of something different. Astronomers were right, but Erin was spinning so fast, about once every 5.5 hours, that if it was made of ice and rock, it should have torn itself apart from the centrifugal force alone, but it didn't. Scientists started to wonder, what is it, and what's it made of? It was time to get in for a closer look. So NASA steered the New Horizons probe in its direction, but something weird happened as the probe approached Pluto. On its way, communications were suddenly lost, as if something was jamming its signal in. As the probe moved away from Erin, communications were again restored, which turned out to be a computer glitch, but NASA was prevented from finding out the truth about the intriguing spinning object. Some researchers suggested that the spinning is creating artificial gravity in the middle of Erin, and it could be some giant ship, something you may have seen in science fiction films. However, the gravity would not be enough for human passengers, but for some other form of alien life it could be. Could this object be an interstellar alien craft of some kind, like Oumuamua? Oumuamua is considered unlikely, but there is always a small chance if you were an alien species and desired a look at the strange creatures known as humans. The Kuiper Belt would be the perfect place to hide. Perhaps, in the future, we'll get another chance to get close and figure out exactly what Erin is still there. Our Kuiper Belt objects we know a lot about. In 2014, astronomers discovered a weird celestial body in the outer reaches of our solar system. Its estimated size was roughly 32 kilometers across. Additionally, its shape, which actually resembles a snowman, is truly intriguing. Scientists have long struggled to understand how such a shape could have formed. The object was named Arrokoth and has been visited by the U.S. space probe in 2019. It's become the most distant space object we ever examined at such a close distance. Arrokoth is an example of the most primitive object in the solar system, so you might think it doesn't have much to offer, but for scientists, flying past Arrokoth was as thrilling as exploring Pluto up close. So what's so special about it? One theory suggests that our solar system formed from a dense cloud of space dust and gas. There is only a tiny fraction of all that material that, when pulled together by gravity, formed the planetary system we see today. Gap here, we don't know what happened in between these stages, and because the average Kuiper Belt temperature is about -370 F or -220 ckBOs are typically well preserved, so they can fill in those gaps, and Arrokoth is one of the missing puzzle pieces in studying this weird-shaped flat object. Scientists came closer to uncovering how space bodies in our solar system were formed. Earth is a contact binary object, meaning it consists of two parts stuck together, and the fact that their colors differ could indicate that they once been separate objects that formed from dust in the primordial cloud over. 4. But how did they meet without seriously harming each other? It turns out that collisions that took place billions of years ago weren't that fast and violent. In the case of this KBO, the two distinct parts began to slowly rotate around one another and came into a slight collision with each other as a result of gravity. Celestial body has an intriguing formation story, and if you'd like to see a video about the birth of our sun and our solar system, let us know in the comments. Still, Aragorn isn't the only mind-boggling object the Kuiper Belt has to offer. The next object isn't famous for its size at 650 kilometers or its shape or color, but the object's strangely low density of 18%, lower than that of water, which means it can easily float. The object has the name 2002 UX25, and its low density is a big mystery. One way to explain it is the celestial body's high porosity, or gaps in its structure. However, it's commonly seen in objects less than 350 kilometers in diameter. Larger objects are too massive for such a low porosity because the force of gravity compresses their material, leaving no room for these gaps. Is this Kuiper Belt object a forensic oddity, something that will change planetary formation theories? Or is it something more complicated? Whatever the reason, we've got to learn more about a vertigized KBO's density to define it for sure. Another intriguing object is almost 4 times the size of UX25, and it's got a lot of stories attached to it. This one's a planetoid, a minor planet that consists of rock and ice, and it's about 300 kilometers wide, but scientists speculate it should have been twice its size. Sometime in the past, it's possible that this KBO had a collision with Pluto and lost its material as a result. What astronomers cannot wrap their heads around is why this object's temperature has risen from about -360 F to -260 F millions of years ago. Did something or someone heat it up? We don't know yet. A Kuiper Belt object has appeared over the past few years. Scientists have found water ice present on its surface. What's more, there could have been an ocean on this planetoid in the past. And that's not all we know about Oumuamua. It also has a bright surface, which could indicate the KBO may have had geological activity such as cryovolcanoes not so long ago. We all know what volcanoes are, but cryovolcanoes are something different. Although they both act similarly, the one with the weird name erupts ice chunks, water, methane, and ammonia instead of magma and ash. As you can imagine, a breathtaking view, and we may one day observe this phenomenon. But there's no planned mission to Oumuamua yet, but if there will be one, we'll make sure to tell you about it. There's also an intriguing space body outside the Kuiper Belt, but it's still worth mentioning once astronomers had discovered and observed it. The object raised tons of questions. One of them was about its mysterious composition. We're used to thinking that the majority of space bodies outside our solar system are made of ice. As a result, they're usually either white or gray. However, what we see with this object is quite different because it's nearly as red as Mars. Another mystery is how oddly this space body moves. Its orbit isn't like anything we've seen before. It's called Sedna, and it moves as close as 11 billion km to the center of our solar system. Then Sedna drifts away to about 135 billion km. It's such a great distance that it needs roughly 0 years to make a full circle. Sedna, along with other celestial bodies, is thought to be a part of a collective gravity. When space objects orbit another object like a binary star, they pull and push on each other, and it affects their orbits. 1. The shocking idea that the extinction of could have been caused by Sedna and other space objects. The dinosaurs, as the orbit of these objects fluctuates, they can shoot nearby comets into the solar system and even towards Earth since Sedna swings back and so forth. It appears that Sedna is being pulled in different directions by an unexpected force, and the force is the hypothetical planet 9, located far beyond the Kuiper Belt. It's estimated to be about 5 to 6 times the size of our planet, although it hasn't been found yet. There's the theory it could be an alien imposter that came from a different star system. Other scientists suggest it's an ancient black hole. Whatever the case is, Planet 9 is supposedly hiding somewhere in our solar system, and it's hard to detect because of the bright row of stars in our Milky Way. However, a recent study suggests it may be closer and brighter than we think, and if it's brighter, it can be easier detected. If found, we could stumble upon a mega-Earth, or a mini-Neptune. So how do we find it? Well, scientists are currently utilizing various telescopes to examine the region of the sky where Planet 9 may be their best chance. But will be the Vera Rubin Observatory equipped with a powerful 8.4 meters telescope when completed? In 2023, the telescope will be repeatedly scanning about 2/3 of the sky, looking for everything from asteroids to the mysterious planet 9. If we discover it one day, it'll become the first time a planet is found in the last 200 years. There are also quite bigger trans-Neptunian objects out there, and some of them are so big they're called dwarf planets. One of the biggest Kuiper Belt objects ever discovered. is also the 25th largest body in the solar system, and there are hundreds of thousands of space objects in it. Although this TNO is nearly 46 astronomical units from us, it's the brightest object in the Kuiper belt, after Pluto. In fact, the object's big size was one of the reasons Pluto was reclassified as a dwarf planet. This Kuiper belt object is called MAC-M, and scientists will struggle to answer why it is bright while its moon, MK2, is as black as charcoal. What's also weird is they expected it to have an atmosphere, but it doesn't have one. All we know is it's very cold, about -400 F 240 C, and these two things make life difficult, impossible, since there are currently no planned flyby missions to M. The next object we discovered in the Kuiper belt has a few mysteries, and this dwarf planet is known for its strange shape to moons and an odd rotation. Plus, this is the most distant space body that has rings around it, and we don't know why the object's name is Hauer, and it's the third closest dwarf planet to our star. The weird shape of this KBO resembles a rugby ball, similar to how you throw a pass as it spun through the air. The balloon's elongated shape was created by filling it with water and making it kind of flatten space. As a result, Hauer's day lasts only 3.9 Earth hours, which is also one of the shortest days in the entire solar system. If you lived on Hauer for 1 year, 1 day equals 4 hours, which is equivalent to 283 years old on a 24-hour Earth day. While the majority of this object is composed of rock on Earth, its outer layer is thought to be covered in ice, just like when you open your freezer, but it also has a strange red spot on it surface that may be rich in minerals, but we're not sure about the origin of this spot just yet. Perhaps it could be something quite different from what scientists are thinking, maybe even a sign of extraterrestrial life. Given how many new things we discover in space, it's possible that we might find alien technology one day. The Galileo project, launched in 2021, is going to try and find alien artifacts in space and here on Earth, and while the chances of finding something significant are small, it could become the breakthrough we've been waiting for since the launch of the first space rocket. Even if the project fails to detect such signs, it could still find eye-opening explanations for Oumuamua and UFOs, the project team claimed. It would make all discoveries publicly available, so stay tuned, as we'll definitely let you know about them when they arrive.